Okay, what can you tell me, what you know about the periodic table? Anything? Yeah, they're about elements, and when you look at the one that's on the west wall, I do believe the numbers are probably, let me get my pointer here. There's more elements that are on this bottom row here, and there might be present on your table, okay? That's probably a little more up to date than what we see here, because this was copyrighted in 1991, okay? So with that, since even though it's 1991, you'll see there's lots of similarities between that of your table and this one. And a couple things I want to point out right away, okay? When you find element number 25, okay? Find element number 25. Not magnesium, close. Manganese, okay? What I want you to do is when you see that box, manganese, you see an element, you see a number of 25. You see another number of 50 something, okay? And then you see a fraction. Does anyone think they know what +2 or +3 means? It's the different charges. So in each one of these boxes, you're going to see the information of the abbreviation of that element, the name of that element, the atomic mass of that element, and the different charges that it can form. Okay? So one of the aspects I want you to add, and one of you two, I don't care which, look at element number 25, and what type of charges does it have, like plus what in there? Okay? So does it say +3 in your box for manganese? I want you to add +3 to that. Okay? So add +3 into that box. Who did not catch that? Add +3 to that. And some of you just may be able to remember that. Maybe. Is that true? Do you need a writing utensil? Okay. So, other aspects that we would like to go over with that is when you look at your table. I'll grab one so we're looking at the same thing. Okay. And that is when you're looking at this table here, over on that block, you see where it says LU right here. What does it say right there, you people sitting on that far left row? It says D block. What I want you to do is where you see lawrencium, element, what is that, 71? It's right here, element 71 and 103 directly beneath it. I want you to put that same bit of information. I want you to put D block right there. Okay? Yeah. So what we see happening then, okay, way over here, we've got element 71 and 103. Okay? This one is LR, this one is LU, okay? So what I want you to do is above that, I want you to put D block. Okay? Then, over here, where it says element 57 and element 89, or right here, see these two elements here, LA and AC? I want you to put F block above them too. Okay? So it says LA and AC. This one's element 89. This one is element 57. I want you to put F block above that. Just above those two examples. Now, one of the things you're going to find out, okay, a lot of the concepts in the fall semester, they built upon one another. That's physics. This is altogether different. It's chemistry. These tend to not build upon one another as much. So, should you fall behind and not decide or ask, I need help, that could be bad. Okay? You fall behind, that you may not find the outcome at the end of this semester what you would have liked or would have hoped. Okay? Because how many college bound do you think? And you might not know I am or am not going to college. College bound people, how many do we have? 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, you individuals that decided to have your hand up, when you're a junior or a senior, you have to take this test to apply for college. Does anyone know what it is? The ACT test. You also have to have what class on your transcript to apply for college. General chemistry. When do you take general chemistry? Your junior year. Okay? Everything that we cover this semester is going to be a precursor or an introduction to what you need to know as juniors. So, when we're having some of these sidebar conversations with people who actually want to try to learn and understand this, and you just want to be doing your own thing, how selfish is that? Not very or pretty selfish? Just a question. Only you can answer that. Okay? So, if you think you'll be taking this class in 2 years, it's really hard to play catch up at that point. Okay? So, for instance, last night, I could really not care less in the Cotton Bowl. It was Texas and Georgia. But when Georgia found themselves down 2 touchdowns in the fourth quarter, it's pretty darn hard to come back in the fourth quarter. Can it be done? Yeah, sure, it can be done, but it's pretty darn difficult. If you find yourself in that predicament in an academic example like this, it's pretty hard to start putting all these concepts together. So please be courteous when people are trying to actually learn and understand this. And for those of you, I'm not going to college, well, this is still part of the South Dakota content standards that you are required to know. All right. So we've covered a couple of things that we want to make sure that we mention. Okay. So what should you have wrote down in element 25? Plus 3. What about above element 71? D block, and above element 57. Okay, you're going to find that when you use this over and over and over again, you're probably going to memorize portions of this. Do you have to memorize this table? No. We don't require you to memorize it. We want you to know how to use it. Okay? Because once you learn how to use it, it's going to make it much, much easier to apply how to use it. Okay? And some of this information you'll be able to put into your long-term memory. Okay? Does anyone know what long-term memory actually is? Do you know your social security number? Okay? Everyone has a social security number. Well, you still have one, you just don't have the card. Your number hasn't disappeared. You're going to need to know that number. Because how many of you want to buy a car? What do you suppose you have to have for that auto loan? Social Security number. In any type of application or financial type, you're probably going to have that number. So one, it's good to make sure you have it. Two, it's even better if you have it memorized. Okay? That's just passing on what I hope is good advice. All right. So, what can you tell me about the periodic table that you learned in earth science? Like, for instance, what's a subatomic particle? Do you know? You're going to find that out, perhaps today even. Okay? And there are 3 of them. Does anyone know what they are? Protons, neutrons, and electrons. Okay, what's the difference, besides naming of those, what's the difference between those subatomic particles?
One's neutral, one's positive, one's negative.
Okay, that's true. Which one's which?
Proton is positive.
Yep.
Neutron's neutral.
Yes. Negative, the only one that's left. Okay? So another aspect I want to mention before I forget, okay? When you look at one of your vocab terms, is probably alkali metals, okay? You're going to say, well, hydrogen, that's not a metal, but yet it's in column 1 with the rest of the alkali metals. How many of you have battery-powered tools? A drill, a saw, whatever. What type of battery is that called? Yeah, rechargeable, I get that, but it actually has a metal ion inside. What is it? Starts with an L. Lithium. Lithium-ion batteries, okay? So on this, you're going to notice, look at element 3, which is lithium. When I'm talking about which element, when I'm saying 3 or 25, that's that element's atomic number. It identifies it and tells you the number of protons. So when we look at element number 3, you look for little number 3 in here. Oh, that's lithium. What else is in there besides, what, 6.7 or 6.9? Okay? And you see a what symbol inside of that? Plus. That just means plus 1. Okay? Like when you see on this table, way over there on the west side, okay, when you're looking at that table, what do you see inside element number 3? You see the symbol, the name, a red 3, the atomic mass, and what else? Plus 1. It actually says plus 1, not just a positive charge, but it says plus 1 somewhere, perhaps in this corner here. Okay? So just a positive sign just means plus 1. Then over here, these halogens in this column, which is number 7, okay, it just has a negative sign. That just means negative 1. Once your eyes met, it was just magic or what? Pretty cool. I just thought that was kind of comical. But when you look at fluorine, chlorine, bromine, and iodine, those are all halogens. Okay? And it has a charge of negative 1, just has a negative sign in there. Okay. So that's some properties of some of these atoms. Their charges, where they're at on the periodic table. Okay? And it's certainly, let's say, organized in a specific manner. A lot of people think, well, these are arranged in increasing atomic mass. Well, a lot of the times you would be correct. The most common one that sticks out is elements 52 and 53. Okay? Yes, I understand that might be a little blurry looking on your table, but element 52 and 53 are which elements? Tellurium and iodine. What's the atomic mass for tellurium? What's the atomic mass for iodine? 126. So that's just one example of arranging these in increased atomic mass is not correct. Instead, in increasing atomic number. That's why you see, look at element number 19, potassium, calcium 20, scandium 21. When you arrange these in an increasing increment of 1, they all gain 1 proton. You cannot add protons to an element. You can change the number of electrons, okay? You can even change the number of neutrons in there. Is anyone, we've heard of carbon-14 dating, right? Has anyone heard of carbon-14 dating? What might you use that for? Yeah, for fossils. What happens, you inject an isotope of carbon. Normally, we use carbon-12. It's in your pencil. There's no lead in your pencil. Instead, it's graphite. Graphite is made of which element? Carbon. That's carbon-12. When you're dealing with carbon dating, that's carbon-14. That means it has 2 more neutrons in it. Okay? And what happens is it has what we call a half-life. And that decomposes at a specific rate. So once half of the materials have decomposed, you put that into a mathematical formula that allows you to try to determine how old a fossil is. That's why they use carbon-14. Okay. So structure of an atom. When we're looking at these, a pure form of an atom is going to be an element. Okay? And they all have those different types of abbreviations. For the time being, we're just going to say element number 28. You're going to say, well, that's nickel. Okay? And again, when you use this over and over, you're going to memorize that probably as well. And no, I don't have a lot of the elements memorized myself, but when you use it over and over, well, then it's pretty simple. We're not going to use this concept quite so much, where charges must add up to 0. What we mean by that is when compounds form. The charges in that compound have to add up to 0, because if it doesn't, then it's unstable. And what that means is on the undercarriage are the chassis of your vehicle. Chassis is a very, very fancy name. What might be a more general term or general characteristic? Rather than chassis, you could say that's the vehicle's what? It's the vehicle's frame, okay? So when tow trucks are maybe used, did anyone watch the Rose Parade yesterday? Rose Bowl Parade? It was at the very end. It was a float of, they're trying to portray 2 locomotives. And it wasn't just, it stalled on the parade route close towards the end. And what had happened, they just couldn't use any tow truck to lift that up because it was so heavy. They had to use one of the semi-tow trucks to lift that up. So when you're pulling a vehicle up onto the tow truck, they're probably putting them hooks somewhere on that vehicle's chassis or what? Frame. You don't want to hook it up to the bumper. Don't do that. Why not? It's just going to rip right off of there. So, and by no means, I'm not a tow truck expert. I'm just speculating. What I'm thinking they probably would do is take those hooks, hook it up to the chassis, and then the winch pulls that onto the back of the truck. Okay? So, the reason I mention that is, do you wash your vehicle in the wintertime? Yeah. Okay? So, you could say, we're not going to wash it because the components inside the door might freeze or the power windows might freeze. But on the undercarriage, okay, your chassis, your frame, what happens to the components of that if you do not get the salt off. Yeah, that is a chemical change, okay? In other words, the major component of steel, which element, number 25, which is what? 26, sorry. Iron, okay? So with that steel will go through a chemical change where it oxidizes, okay? Because this is looking way into the future for you people. When we talk about iron 2 oxide, you have that floating through your body like you wouldn't believe, which you need to, because it's a portion of the blood we call hemoglobin. Your oxygen floating through your body has to have a metal ion to bond to, and it does that very easily with iron, okay? But iron 3 oxide, on the other hand, the moisture with water combining, sitting on the steel, will actually cause that to rust. So that's an oxidation process. There, the charges sometimes don't add up to zero because it's going through the oxidation process, and when that happens, that's when problems can occur. You get a hole in your floor, maybe. That's pretty extreme, I get that. I mean, it's not one of them things, oh geez, we talked about this in science class. We gotta go wash our vehicle or else we're gonna get a hole in our floor. No, that's not what we're saying. Okay? So in this case, probably how many of you think you know quite a few names of the elements on the table? I mean, even just with this one, these man-made or synthetic elements goes up to 103, but typically, well, that's where it ends, is 103 there. By the time this class ends, you probably will have maybe 30 or 40 of these memorized, just won't even realize it. So what we mean by that, saying sometimes these Latin names are used, okay? So the reason we say that is, okay, those three abbreviations, which one of them is iron? None of them. None of them are iron. Okay? Because this is iodine, this is indolium, and this is iridium. But then when we look at iron, well, why can't it be just I? Well, that's already taken. Why can't it be IR? Well, that's iridium. Why can't it be IN? Well, that's indolium. When you look at what? Okay? When you look at element number 26, okay, that is what? Iron. And that has the symbol of this, okay? So, let's say, for instance, you go to a metal recycling place, okay? And they take a take a magnet. Oh, that is a non-ferrous metal. If it's a non-ferrous metal, that means it doesn't have any what in it? Iron. Okay? Ferrous is Latin for, surprise, surprise, iron. Okay? So if you wanted to find the element tungsten, I thought that might be a surprise, that someone might be looking and looking and looking. I can't find tungsten. Well, what's the abbreviation for tungsten? How in the world do you get W for tungsten? Well, it's a Latin term. The Latin word for tungsten is wolfram. That's why it's W. Okay? So sometimes some of those abbreviations are used to avoid this different array of, if you want to say, confusion that can happen with this. Okay? I want to say, was it Thanksgiving break or shortly thereafter? There were some teenagers. I don't know if it was Colorado. They entered this type of a mine looking for it. It was an abandoned one. Copper. Well, is copper CO? No, it's Cu. Again, a Latin term. Cuprous means copper. All right. So when you're looking for some of these abbreviations, you're not always going to be looking for the first letter or first two letters of that element's name. Sometimes Latin names are used. All right. So when we're looking at some of these, okay, we see the components that make up that atom, which means it has a nucleus and an electron cloud. Want some happier thoughts. I do know we do have a warm-up in coming the next few days, if you believe the weatherman. Track season. I know we're still in basketball season, but if we foreshadow a little bit into the next, let's say, 2.5 months from now, how many track people do you think you are? So this row, how many track? This row, this row, this row, okay, and then this row, okay. So one of the reasons we go through that is when we get closer to when that track season hits, you're going to possibly be having to go back and, if you choose to, okay. No one's going to force you to go back to the Science Channel and watch to see what you missed. But there's probably going to be, or possibly going to be, some important information. Should you miss that time, it's an opportunity to see the content or information that you had lost. Or not lost, but maybe missed during that school day. Okay. So with that, does anyone have this information that wants it? Okay. So, we don't have much time. We will continue on talking about this periodic table and what the electron cloud is tomorrow. Okay. I would highly suggest that you find a scratch sheet of paper for tomorrow, whether it's just a back side, probably with no, you can use notebook paper, but if you have a blank sheet like this, it'll be a lot better for you. Okay? All right, we'll pick up with this tomorrow.